Hello friends, welcome back to my YouTube channel Maths by Samit Deshmukh. So today we are solving the example from exercise 2.2. In the last video we have seen how to find out minor of element of a square matrix, cofactor of element of square matrix and adjoint of a square matrix. Using this result we are solving the example from this exercise. So if you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded video. Even if you like the videos, share the videos with your friends also. So see, in the first example we have to find out cofactor of element of given square matrix. So here one matrix of order 2 by 2 in example number first is given to us and we are finding cofactor of every element. So total 4 elements are there, means we have to find out cofactor of every element. And cofactor of elements can be find out applying which formula? Aij is equals to minus 1 raised to power I plus j into mij. Applying this formula we are able to find out cofactor of the element. So here let us try to find out cofactor of first element. First element lies in first row and first column. This 2 lies in what? First row and second column. This minus 3 lies in second row first column and 4 lies in second row second column. Means these are the 4 cofactor of all the element which we have to find out applying this formula. So let us substitute the values in this formula. Minus 1 raised to power I plus j. Here I is 1, j is 1. Means 1 plus 1 into m11 is equal to, here what will get? Minus 1 raised to power 1 plus 2 into m12, because I is 1 and j is what? 2. Just substitute the value of I and j in this formula. So here we will get minus 1 raised to power 2 plus 1 into m21. Here we will get minus 1 raised to power 2 plus 2 into m22. Now substitute the values, means simplify it. Here we can observe that minus 1 its power is what? Plus 2, and whenever the power of minus 1 is even number, at that time its value is what? Plus 1. Here power of minus 1 is odd number, so here its value is minus 1. Again 2 plus 1 means 3, means power is what? Odd number, that's why we can say that its value is minus 1. And here power of minus 1 is 2 plus 2 means 4, means even number, that's why we can say that its value is plus 1. Now value of this first term is known to us. Now we are finding value of minor. We know that minor is nothing but determinant. To obtain the element of this determinant, delete the element of first row and first column. Delete first row, first column. What will get here? Minus 3. Now minor of the element lies in first row and second column. For that purpose delete first row and second column. Here delete first row, first column. Delete first row, first column. We will get what? 4. Sorry, here we will get 4. Now we are deleting first row, second column. First row, second column, we will get minus 3. Now delete second row, first column. Second row, first column, we will get 2. Here delete second row, second column. Second row, second column, we will get minus 1. In this determinant, isn't it? Once the element in the determinant are known to us, simplify the determinant. We know that if only one number is there in the determinant, at that time whatever will be that number will be the value of determinant. So means value of this determinant is 4. 4 into 1 will be equal to 4. Here value of determinant is minus 3. Minus 3 into minus 1 is plus 3. 2 into minus 2 is minus 2. Minus 1 into 1 will be equal to minus 1. In this way we have got the cofactor of all the elements. Now let us try to solve the second example. In this second example also total 9 elements are there and we are trying to find out cofactor of all these 9 elements, where cofactor of first element is denoted by A11, second element is denoted by A12, and what is the formula to find out cofactor? Minus 1 raised to power I plus j, means here 1 plus 1 into m11 is equals to, here what will get? Minus 1 raised to power 1 plus 2 into m12. Then third element lies in first row and third column. So its minor is minus 1 raised to power 1 plus 3 into m13. In the same way, find out minor of every element. So this element lies in second row first column. Second row first column. The next element lies in second row second column. Next element lies in second row third column. Next element lies in third row first column. Then third row second column. And lastly third row third column. So again apply the same formula, minus 1 raised to power I plus j. Here I is 2 and j is 1. So into m21. Here what we'll get, minus 1 raised to power 2 plus 2 into m22. Here what we'll get, minus 1 raised to power 2 plus 3 into m23. Here minus 1 raised to power 3 plus 1 into m31. Minus 1 raised to power 3 plus 2 into m32, and here minus 1 raised to power 3 plus 3 into m33. Okay, just we have substituted the value of I and j in the formula of what? Cofactor, where its formula is this one, minus 1 raised to power I plus j into mij. Now observe here, we are finding value of first term. First term means what? Minus 1 raised to power n, minus 1 raised to power n. We know that if power of minus 1 is even number, at that time its value is plus 1, and odd number, at that time its value is minus 1. Here power of minus 1 is even, so its value is plus. Here odd, so its value is minus 1. Here even, 1 plus 3 is what? 4, and 4 is even, so its value is plus 1. Here again odd, so minus 1. Here again even, so plus 1. Here odd means minus 1. Then what? Even means plus 1. 3 plus 2 is 5. Odd means minus 1. And 3 plus 3 is 6, means what? Plus 1. Means easily we can observe that in the first case power is even, then odd, then even, then odd, then even, continuing this way. Means what we'll get? Plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. In every example, if its order is 3 by 3, we should not have to do the same calculation in every example. Just you have to remember that in the first term value it's plus 1, then minus 1, plus 1, plus minus 1, plus 1, continuing this way. Means starting is also with plus 1 and ends also with what? Plus 1. But remember this method in case of order 3 by 3. If order of the matrix is 2 by 2, at that time we are getting plus 1, minus 1, minus 1, plus 1. Means starts with 1 and end with 1, and in between in the middle two steps it value will be equals to what? Minus 1. यानी फर्स्ट केस में प्लस 1 आता है, लास्ट केस में प्लस 1 आता है, और बीच के दोनों भी केस में माइनस 1 आता है if the order is what? 2 by 2. But if the order is 3 by 3, at that time the value of first term, easily we are able to remember that plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, continuing this way. Is it clear? So every time not necessary to perform the calculation, simply we are able to remember the value of what? At least value of first term. Now what is our second term? Second term is to find out value of minor, and to find out value of minor is nothing but what? Determinant. To obtain the element of determinant, delete first row and first column. Delete first row, first column, which are the remaining element 3, 5, 0, minus 1. Now delete the element of first row, second column, first row, second column. Remaining elements are minus 2, 5, minus 2, minus 1. Then delete the element of first row, third column, which are the remaining element minus 2, 3, minus 2, 0. Now delete the element of second row, first column. Remaining elements are minus 1, 2, 0, minus 1. Then delete the element of second row, second column, second row, second column. 1, 2, minus 2, minus 1 are the element. Then delete the element of second row and third column, second row, third column. What we are getting? 1, minus 1, minus 2, 0. Now delete the element of third row and first column, third row, first column, which are the remaining element minus 1, 2, 3, 5. Now delete the element of third row, second column, third row, second column. Remaining element are 1, 2, minus 2, 5, and lastly delete third row, third column, third row, third column. Remaining element are 1, minus 1, minus 2, 3. Using this method we are able to obtain the element of the determinant. Now remaining part is just to find out the value of determinant and complete the calculation part. So now let us try to find out value of first determinant. Whenever we are finding value of determinant, first take the product of diagonal element minus product of off diagonal element. Minus 3 minus 0 is minus 3. Minus 3 into 1 will be equal to minus 3. Now here this product is 2 and this product is minus 10. 2 minus minus 10 means plus 10. 2 plus 10 is what? 12, and 12 into minus 1 will be equal to minus 12. Now here this product is 0 minus minus 6 means plus 6. 0 plus 6 is 6. 6 into 1 will be equal to 6. This product is 1 minus 0. 1 minus 0 is 1. 1 into minus 1 is minus 1. So if you are not able to perform the calculation orally, so perform the calculation in rough or write down here what result we are getting. First take the product of diagonal element minus product of off diagonal element. Observe here, product of diagonal element is minus 1 minus minus 4 means minus 1 minus minus means plus 4. Minus 1 plus 4 will be equals to 3 and 3 into 1 will be equal to 3. Here 0 minus 2 will be equals to 2. 2 into minus 1 is minus 2. Here minus 5 minus 6 is minus 11. Minus 11 into 1 is minus 11. Here we will get 5 minus minus means plus 4. 5 plus 4 is 9. 9 into minus 1 is minus 9. Again observe, 5 plus 4 is 9. 9 into minus 1 is minus 9. Here this product is 3. 3 minus 2 will be equals to 1 and 1 into 1 will be equal to 1. So in this way we are finding cofactor of element of a matrix. Now see, in the question number 2 we have to find out matrix of cofactors of the following given matrices. To find out matrix of cofactor, first we have to find out cofactor, and later on we have to collect all these cofactor in a matrix which is called as matrix of cofactor. In the last example we have seen how to find out cofactor. So using same method we are finding cofactor of the element of given matrix. So already we know that first a cofactor of first element is denoted by a11, second by a12, third by a21, and this element lies in what? Second row and second column. So its cofactor is denoted by a22. Formula I have already written to save our time. Now only remaining part is to substitute the value and find the value of these cofactors. So we know that minus 1, here power is even, so its value is plus 1. Here power is odd, so that's why we can say that its value is minus 1. Here power of minus 1 is odd, so its value is plus 1. Here even, so here its value is plus 1. Here odd, so its value is what? Minus 1. Simply we have to remember that plus 1 minus 1 minus 1 1 appears if the order of the matrix is what? 2 by 2. And in our syllabus we are studying about matrix of order 2 by 2 and 3 by 3. तो दो ही टाइप के matrices हो सकते हैं. If the order is 2 by 2, then 1 minus 1 minus 1 1 will be the value of what? First term. Now remaining part is just to find out the value of minor. To find out value of minor, its value is determinant. To obtain the element of determinant, delete first row first column. First row first column. First row first column. So what we are getting here? Minus 1. Now delete first row second column. First row second column, so we are getting 4. Here delete second row first column, so we are getting 3, and delete second row second column, we will get 1. So which is equal to, now see here value of this determinant is minus 1 because only one element is there in the determinant. Whenever one element is there in the determinant, that element itself will be the value of that determinant. It is not mod. Don't change the sign of minus 1. It is determinant. So determinant of minus 1 is minus 1. And minus 1 into 1 is minus 1. Here 4 into minus 1 is minus 4. 3 into minus 1 is minus 3. And 1 into 1 will be equal to 1. In this way, we have got the cofactor of all the element. Collect all these cofactor in a matrix. So minus 1, minus 4, minus 3, 1. Since we have collected all the cofactor in this matrix, that's why this matrix is called as matrix of cofactor. Now see the second example. In the second example, total 9 elements are there in this matrix and we are finding cofactor. First cofactor of all the 9 elements. In case of order 3 by 3, what we have seen, value of this first term is here what? Plus 1 because power is even. Then what? Minus 1, plus 1, minus 1. Why we are getting such type of result? That already we have discussed in the last example, isn't it? तो क्या मिलता है हमें, अगर 3/3 का मैट्रिक्स है तो +1 -1 +1 -1 continuing this way, last term will be what, +1, because here power is even then odd then odd, continuing this way. So that's why easily we are able to remember what is the value of first term. Now to find out value of minor, use the determinant, because minor is determinant, and to obtain the element of this determinant, delete first row and first column. First row, first column, which are the remaining element, 1 3 3 -5. Now delete first row and second column. First row, second column, which are the element -2 3 0 -5. Now delete first row and third column. What we are getting here, -2 1 0 3. Now delete second row and first column. Second row, first column. What we are getting, 0 2 3 -5. Then delete second row, second column. Second row, second column. What we are getting, 1 2 0 -5. Then delete second row and third column. Second row, third column, 1 0 0 3. 1 0 0 3. Now we are deleting third row and first column. Third row, first column. What we are getting, 0 2 1 3. Now delete third row and second column. Third row, second column, 1 2 -2 3. 1 2 -2 3. And lastly delete third row and third column. Third row, third column. What we are getting, 1 0 -2 1. So once the values are substituted, so find the value of determinant and complete the calculation part. So here -5 -9 is -14. -14 into 1 is -14. Value of this determinant, 10 - 0 is 10, and 10 into -1 is -10. Here -6 -0 is -6. -6 into 1 is -6. Here 0 -6 is -6. -6 into -6 is -1 is +6. -5 -0 is -5. -5 into 1 is -5. Here 3 -0 is 3. 3 into -1 is -3. Here 0 -2 is -2. -2 into 1 is -2. Then here 3 minus means +4. 3 + 4 is 7, and 7 into -1 will be -7. And lastly 1 - 0 is 1. 1 into 1 will be equal to what? 1. In this way we have got the cofactor of all the element. So now collect all these cofactor in a matrix. So -14, then -10, then -6, later on 6, -5, -3, -2, -7, 1 are the elements of matrix of cofactor. Now see, in question number 3 we have to find out adjoint of the given square matrices. So to find out adjoint of a given square matrix, first step is to find out cofactor of all the element, then collect all these element in one, all the cofactor in one matrix, which is called as matrix of cofactor, and they taking its transpose we are able to find out adjoint of a matrix. Means what is our first step to find out cofactors? So already the formula is written here, so to save our time, so here value of -1 raised to power 2 is 1. Then here we are getting -1 since power is odd, here also -1 since power is odd, and here power of -1 is even, so we are getting +1. Now to obtain the element of this determinant, delete first row, first column. Here we will get 5. Here delete first row, second column, so we will get 3. Here delete second row, first column. Second row, first column, so we are getting -3. And here delete second row, second column, so we will get 2. Once the element of the determinant are known to us, so find out the value of determinant and complete the calculation part. So here determinant of 5 is 5. 5 into 1 will be equal to 5. Here 3 into -1 is -3. -3 into -1 is +3, and 2 into 1 will be equals to 2. Cofactors are known to us. Collect all these cofactor in one matrix. So what we'll get here, 5 -3 3 2. We have collected all these cofactor in one matrix. Once the cofactors are collected in the matrix, which is called as matrix of cofactor. Now to find out adjoint of the matrix, so this implies that adjoint of matrix A, if we are denoting this matrix A by A, let us denote this matrix by A. Let A is the given matrix. So adjoint of this matrix is denoted by this notation, and to obtain the element of this matrix, take the transpose of matrix of cofactor. Means convert first row into first column, 5u minus 3. Convert second row into second column, 3, 2. In this way we are getting adjoint of a matrix. Now to check whether our answer is correct or not, already I have told you one shortcut method which is applicable only if the matrix is of order what, 2 by 2. Check whether these two elements are interchanged. Yes, these two elements are interchanged, and check that sign of these two elements are changed or not. Here minus 3 is there, so here we will require plus 3. Yes, we have got plus 3, and here plus 3 is there, so we will require here minus 3. Yes, sign of these two elements get changed and these two elements will get interchanged, means we can say that our calculation part is correct. This method is applicable only in case of a square matrix of order 2 by 2. Now let us try to find out adjoint of this given matrix. Here also I am denoting the given matrix A by B. So let us denote this matrix by B. Now to find out adjoint, first find out the cofactors. Already all the steps are written here just to save our time. Okay, now complete the calculation part. Here minus 3 minus 0 is minus 3, minus 3 into 1 is minus 3. Hope now these steps are very clear to you, because we are repeating such type of step in last two example. So how we have got the element of this determinant is also now I think very clear to you. Now here what we are getting, 2 minus minus means plus 10. 2 plus 10 is 12, 12 into minus 1 is minus 12. 0 minus minus means plus 6, plus 6 into 1 is plus 6. Here 1 minus 0 is 1, 1 into minus 1 is minus 1. Here minus 1 minus minus means plus 4, minus 1 plus 4 is 3, and 3 into minus 1 is minus 3. Here 0 minus 2 is minus 2, minus 2 into minus 1 is plus 2. Minus 5 minus 6 is minus 11, minus 11 into 1 is minus 11. Here 5u minus minus means plus 4, 5 plus 4 is 9, 9 into minus 1 is minus 9. And here 3 minus 2 is 1, 1 into 1 will be equals to 1. In this way we have got cofactor of all the element. Now collect all these cofactor in one matrix which is called as what, matrix of cofactor. So what we are getting here, minus 3, minus 12, 6, then minus 1, minus 3, 2, minus 11, minus 9 and 1. Once the matrix of cofactor is known to us, easily we are able to find out adjoint of a matrix. So one small correction is there, try to understand it. Here minus 1 minus minus means plus 4. Minus 1 plus 4 will be equals to 3, and 3 into 1 will be equals to 3. So here we are getting 3. So here also we will get what, 3. So in this way we have got the matrix of cofactor. Now take its transpose to find out adjoint. So this implies that adjoint of matrix B will be equals to, because matrix we have denoted by B, and to find out adjoint of a matrix, just simply we are taking transpose of this matrix. Means while finding transpose we are converting row into column. So here element of first column are minus 3, minus 12, 6. To find out element of second column, convert second row into second column, minus 1, 3, 2. Now lastly convert third row into third column, that is minus 11, minus 9, 1. In this way we have got adjoint of this matrix. Now see the example number 4th from this exercise. In this example one matrix is given to us and we have to verify that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I or not. So to solve this example we will require matrix A which is already given to us, and we will require adjoint of this matrix also. So first let us try to find out adjoint of this matrix. Remember that why we are solving this example, because we are getting one very important condition which can be helpful to solve the objective type questions, isn't it? So first try to understand this condition, and later on we will see how to utilize this condition while solving objective type questions. Okay, so which is nothing but very one shortcut method. So to find out multiplication of A and its adjoint, that part we will discuss later on. First let us try to solve this example. So we are finding adjoint of this matrix. To find out adjoint, first we have to find out cofactor. Already we know how to find out the cofactor. Here M11 means its value is determinant. Already some values we have got here. How we have got this value, that we have seen in first three examples. Now here delete first row and first column, which are the element 0, -2, 0, 3. Now delete first row, second column, what we are getting 3 - 2, 1, 3. 3 - 2, 1, 3. Now delete first row, third column, we will get 3, 0, 1, 0. Now delete second row and first column, what we are getting -1, 2, 0, 3. Now delete second row, second column, 1, 2, 1, 3. We are getting 1, 2, 1, 3. Delete second row and third column. Second row, third column, 1, -1, 1, 0. Now delete third row, first column. So what we are getting, -1, 2, 0, -2. Then delete third row, second column, 1, 2, 3, -2. 1, 2, 3, -2. Then delete third row, third column. What we are getting, 1, -1, 3, 0. So now find the value of determinant and complete the calculation part. Here 0 - 0 is 0, 0 into 1 is 0. So here 9 minus means +2. 9 + 2 is 11. 11 into -1 is -11. 0 - 0 is 0, 0 into any term is 0. Here -3 - 0 is -3. -3 into -1 is +3. Here 3 - 2 is 1. 1 into 1 is 1. Here 0 minus means +1. 0 + 1 is +1. 1 into -1 is 1. 0 + 1, 1. 1 into -1 is -1. Here 2 - 0 is 2. 2 into 1 is 2. Here -2 - 6 is -8. -8 into -1 is +8. Here 0 minus means +3. 3 into 1 will be equals to 3. So collect all these cofactor in one matrix. So 0, -11, 0, 3, 1, -1, 2, 8, 3. And since we have collected all the cofactor in one matrix, so it is called as matrix of cofactor. Once the matrix of cofactor is known to us, taking its transpose, we are able to find out adjoint. So therefore adjoint of matrix A will be equals to. So now take the transpose of this matrix, means convert first row into first column, that is 0, -11, 0. Convert second row into second column, that is 3, 1, -1. Then convert third row into third column, 2, 8, 3. Once the adjoint of a matrix is known to us, then to find out our first required value, we have to take the multiplication of A and adjoint of A. So therefore A into adjoint of A will be equals to. So write down the element of matrix A. What are its element? 1, -1, 2, 3, 0, -2, 1, 0, 3. Then write down the element of adjoint of this matrix. So already adjoint of matrix is known to us. So what are its elements? 0, 3, 2, -11, 1, 8, 0, -1, 3. Whenever we are finding a product of two matrices, we are multiplying by row to what? Column. So which is equal to, already we have seen how to take the multiplication of two matrices. So now to get the element of this first row, we are multiplying by first row to first column, then second column, then third column. So observe the multiplication very carefully. Here 1 into 0 is 0, -1 into -11 is 11, and 2 into 0 is 0. Means 0, 11, 0. So will be equal to 11. Now I am multiplying by first row to second column. So 3, 1, 2. So here what we are getting? 3 -1 -2. 3 -1 -2 is 0. Then multiply to the third column. So observe, I am multiplying by first row to third column. 2 -8 plus 6. 2 minus 8 plus 6 will be equals to 0. Now I am multiplying by second row. Since I am multiplying by second row, so we will get the element of second row. So multiply by second row to this column, 0 plus 0 plus 0 will be equals to 0. Now multiply to the second column, 9 plus 0 plus 2. 9 plus 0 plus 2 will be equal to 11. Multiply to the next column. So here we will get 6. 0 minus 6. 6 0 minus 6 will be equal to 0. Now we are using the third row, so we here also will get the element of third row. Multiply by third row to first column, 0 0 0. So here we will get 0. So 3 0 minus 3. 3 0 minus 3, their addition is 0. Multiply to the last column, 2 0 9. 2 plus 0 plus 9 will be equal to 11. Let us denote it by equation number first. In this way we have got the value of first term. Now we are finding value of second term, means we are finding value of adjoint of A into A. So first write down the element of adjoint. These are the element of adjoint: 0 3 2 minus 11 1 8 0 minus 1 3, and element of A are 1 minus 1 2 3 0 minus 2 1 0 3. Now just simply we have to take the product of these two matrices, and whatever may be the result we are getting, we are denoting it by question number 2. So take the multiplication here, multiply by row to the column. So multiply by first row to first column, 0 9 2. 0 plus 9 plus 2 is 11. Now multiply to the second column, 0 plus 0 plus 0 will be equal to 0. Multiply by first row to third column, 0 minus 6 plus 6 will be equal to 0. Now I am using I am multiplying by second row, so here also we will get the element of second row. Multiply by second row to first column, minus 11 plus 3 plus 8. Minus 11 plus 3 plus 8 is 11, minus 11 plus 11 will become 0. So multiply by this row to next column, 11 0 0 will be 11. Multiply by second row to third column, minus 22 plus 2 minus 2 plus 24. Again observe, minus 22 minus 2 means minus 24. Minus 24 plus 24 will be 0. Now I am making the use of third row. If we are making the use of third row, here also we will get the element of third row. So multiply by third row to first column, 0 minus 3 plus 3 will be 0. Multiply to the second column, 0 0 0 will be 0. 2 9. 0 plus 2 plus 9 is 11. So from these two result, or from equation first and second, we can observe that first two terms are equal. Now to find out the value of last term, first we have to find out determinant of A. So therefore, and determinant of A will be equals to, determinant of A is equal to, write down all the element of matrix A in the determinant. What are its element? 1 minus 1 2 3 0 minus 2 1 0 3. How to simplify the determinant, that part we have already studied in class 11th. So here 1 keep it as it is, delete this column, 0 minus 0 is 0, then here minus 1 is there, then we are writing here plus 1, and delete this column, find out the determinant of these four elements. 9 minus minus means plus 2, 9 plus 2 is 11. Lastly, plus 2 into, delete this column, 0 minus 0 is 0. So we can observe that here we are getting 0, here also 0, and here 11 ones are 11, means value of determinant will be equals to what? 11. Now I am multiplying by determinant of A to identity matrix. So determinant of A into I will be equals to, what is the value of determinant? 11. Value of determinant will be equal to what? 11. And I means identity matrix. So identity matrix, its elements are 1 0 0 0 1 0 0 0 1. Isn't it? So which is equals to, now multiplying by 11 to this matrix means multiplying by 11 to all the element of this matrix. So multiply by 11 to all the element of this matrix, 11 0 0 0 11 0 0 0 11. So let us denote it by equation number 3, and here we can observe that all these matrices are what? Equal matrices. That's why we can conclude that. So from equation first, second and third, what we can conclude? So later on continue this part here. So from equation first, second and third, we can say that these three values are what? Equal, isn't it? After equation number 3, we have continued our solution here, and we can observe that from these three equations we can say that these three terms are equal. Now if question is asked to find out A into its adjoint and one matrix A is given to us, what will be our step? Find out the adjoint. To find out adjoint, first find out cofactor of all the element, then find out matrix of cofactor, then taking its transpose we will get what? Adjoint. And later on taking multiplication of A and its adjoint we will get this matrix. But now instead of using this long method, so what we have seen that this product means A into its adjoint or adjoint of A into A is equal to what? Determinant of A into I. So easily we are able to find out value of determinant hardly within 1 or 2 steps, isn't it? And once the value of determinant is known to us, whatever may be the value of determinant will be the diagonal element. And we can observe that both the matrices are what? Scalar matrices. Scalar matrices means non-diagonal elements are 0. Means what important condition we are getting? Multiplication of A into its adjoint or adjoint of A into A is always what? Scalar matrix. Scalar matrix means diagonal elements are constant and non-diagonal elements are 0. अभी हमें ये तो पता चल गया है कि non-diagonal element 0 है, तो बचता क्या है? Just to find out value of diagonal element, and we have seen that value of this diagonal element 11 is nothing but value of what? Determinant. Means to find out this multiplication, just simply whatever may be the matrix A is given to us, find out its determinant, and whatever may be the value of determinant we are getting will be what? Diagonal element of that scalar matrix. यानी ये multiplication find करने के लिए ये सब long method use करने की जरूरत नहीं है. Just we have to find out determinant of matrix, and whatever may be the value of determinant we are getting will be the diagonal element of this scalar matrix, isn't it? A into its adjoint is scalar. Scalar matrix means non-diagonal elements are 0. Then to find out value of diagonal element, just find out determinant of that matrix. Value of determinant is the value of diagonal element of that scalar matrix. In this way we have solved first 4 examples which are related with what? Minor, cofactor and adjoint. In the next video we will solve the remaining example which are related with what? Inverse of a matrix. So first we will discuss what is the definition of inverse. Later on we will see which are the method to find out inverse of a matrix in our syllabus, and applying that method we will solve the remaining example in the next video in this exercise. So if you like the videos, please share the videos with your friends. Thank you.